All right, section 2.2, we are continuing to talk about chemistry. And when we talk about chemistry, we have to talk about a couple definitions and terms. And we started to talk about these definition terms. We're just going to tweak them a little bit. And what I mean with how we've started to talk about them already is we've talked about physical changes and chemical changes. And what's the difference between a physical change and a chemical change? Remember, a physical change doesn't change the property of the substance. A chemical change does change the property of the substance. So what we're looking at here is slightly different. We have properties of matter, and it's kind of the same but slightly different. So if we look at physical properties, it's used to identify a material or separate the substance within a mixture. So what are some physical properties? Well, melting point. What does water melt at in Celsius? 0, or freezes at 0. What does water boil at in Celsius? 100. We talked about the density of water earlier in chapter 1. The density of water is 1, or 1,000 kilograms per meter cubed. So what are some examples of physical properties? There's something we can kind of tie a number to. All right, melting point, density like we talked about. What is viscosity? Does anyone know what viscosity is? It's kind of how quickly something pours out. So if you talk about something that's high in viscosity, it's going to have a hard time pouring out. So like molasses has a high viscosity. How about motor oil? Motor oil pours out really, really, really quick. So motor oil would be an example of a low viscosity. So physical properties, things we can attach a number to. Melting point, density are just examples. We talked about boiling point. Those are things we can attach numbers to. Chemical properties are really only properties that can be observed when it changes. So undergoes a chemical reaction. Now if you remember the iodine clock challenge where I turned the beakers blue after they mix together for a couple minutes, that's a chemical property. But why does that happen? Well, because starches like to react with iodine to form black colors. That's why that happens. So reactivity, flammability. Reactivity is a big one. We're going to talk about, in 2.1 we talked about the elements. The elements are put on the periodic table in the order in which they're going to react. So some of the elements are very reactive and others not so much. And that's a chemical property. Also, how well they get along with other elements, that's a chemical property. If it blows up, that's a chemical property. If it starts on fire, that's a chemical property. All things that we need to talk about when we talk about matter. All right, now we talked about the periodic table in 2.1. The periodic table breaks down mostly into solids, but what are the 3 states of matter? We have solids. What defines a solid? Well, it has a definite shape. That chair you're sitting in right now has a definite shape. That shape is not going to change. It also has a definite volume. It's going to take up the space no matter what happens. That chair is always going to take up that same amount of space. So definite shape, definite volume. And the molecules are the closest together. So molecules are the closest together in solids. Then we talk about liquids. Liquids have a definite volume but not a shape. Right? I can measure out 100 milliliters, but what's the shape of 100 milliliters? It could be the size of the graduated cylinder I poured it in, or the beaker I poured it in. Or what if I dumped 100 milliliters of water on the floor? What shape is that going to take? Right? So liquids do have a definite volume but not a definite shape, and their molecules are intermediate together. They're not the closest together, but they're not the farthest apart. So the molecules are intermediate in distance. So we have solids, definite volume, definite shape. Liquids, just definite volume, no definite shape. And gases defy everything. Gases have no definite shape and no volume. What's the shape of a gas? The room? You go outside the room, there's still gas there. What's the volume of the gas? The room? I can compress that if I wanted to. So gases have no definite shape and no definite volume, and their molecules are the farthest apart. So we have solids, which the molecules have a definite shape and definite volume. Liquids, just a definite volume, no definite shape. And gases are molecules which are the farthest apart and have no definite shape or volume. Now there is a fourth phase of matter that we can talk about, and that is plasma. And all I want you to know is that plasma is the fourth phase of matter. Right. Plasma is kind of complicated. It exists at very high temperatures. All I want you to know about plasma is it's the fourth phase of matter. That's it. Plasma is the fourth phase of matter. So we have solids, liquids, gases, and plasma, and that is it for section 2.2.